List. The list interface extends collection and declares the behavior of a collection that stores an ordered collection of elements, also known as a sequence. Elements can be inserted or accessed by their position in the list using a zero-based index. A list may contain duplicate elements. List is a generic interface that has this declaration: interface list angle brackets E. E specifies the type of objects that the list will hold. The angle brackets E indicate that the interfaces are generic in design. When you construct an instance of these generic types, you need to provide the specific type of objects contained in these collection. In addition to the methods defined by collection, list defines some of its own. Note that several of these methods will throw an unsupported operation exception if the list cannot be modified, and a class cast exception is generated when one object is not compatible with another, such as when an attempt is made to add an incompatible object to a list. Also, several methods will throw an index out of bounds exception if an invalid index is used. A null pointer exception is thrown if an attempt is made to store a null object, and null elements are not allowed in the list. An illegal argument exception is thrown if an invalid argument is used. To the versions of add method and add all method defined by collection, list adds the methods add int e and add all int collection. These methods insert elements of the specified index. The semantics of add e method and add all collection method defined by collection are changed by list so that they add elements to the end of the list. You may modify each element in the collection by using the replace all method. To obtain the object stored at a specific location, call the get method using the index of the object. To assign a value to an element in the list, call the set method by specifying the index of the object to be changed. To find the index of an object, use the index of method or the last index of method. You can obtain a sublist of a list by calling sublist method, specifying the beginning and ending indices of the sublist. As you can imagine, sublist method makes a list processing quite convenient. One way to sort a list is with the sort method defined by list. Beginning with JDK9, list includes the of factory method, which has a number of overloads. Each version returns an unmodifiable value-based collection that is comprised of the arguments that it is passed. The primary purpose of the of method is to provide a convenient, efficient way to create a small list collection. Set. The set interface defines a set. It extends collection and specifies the behavior of a collection that does not allow duplicate elements. Therefore, the add method returns false if an attempt is made to add duplicate elements to a set. With two exceptions, it does not specify any additional methods of its own. Set is a generic interface that is declared interface set angle brackets E. E specifies the type of objects that the set will hold. Beginning with JDK9, set includes the of factory method, which has a number of overloads. Each version returns an unmodifiable, value-based collection that is comprised of the arguments that it is passed. The primary purpose of the OB method is to provide a convenient, efficient way to create a small set collection. Sets can be useful for storing collections, such as a deck of cards or student records. Iterator. Collection extends the iterable interface. This means that all collections can be cycled through by the use of an iterator or by the for each style for loop. Thus, an iterator provides a means of enumerating the contents of a collection. Because each collection provides an iterator, the elements of any collection class can be accessed through the methods defined by iterator. With only small changes, the code that cycles through a set can also be used to cycle through a list to obtain or remove elements. Iterator is a generic interface declared as interface iterator angle brackets E. E specifies the type of objects being iterated. Before you can access a collection through an iterator, you must obtain one. Each of the collection classes provide an iterator method that returns an iterator to the start of the collection. By using this iterator object, you can access each element in the collection, one element at a time. In general, to use an iterator to cycle through the contents of a collection, you follow some steps. Number 1. Obtain an iterator to the start of the collection by calling the collection's iterator method. Number 2. Set up a loop that makes a call to hasNext. Have the loop iterate as long as hasNext returns true. Number 3. Within the loop, obtain each element by calling next. For collections that implement list, you can also obtain an iterator by calling list iterator. As explained, a list iterator gives you the ability to access the collection in either the forward or backward direction and lets you modify an element. Otherwise, list iterator is just like an iterator. Here is an example of using an iterator. This code snippet shows the creation of an array named alphabet. The array named alphabet is an array list, which is an implementation of the list interface. It is populated with 5 elements and printed using an iterator. The result of this code snippet is shown on the right.